All right. Hello, everyone. Hey, everyone. Welcome to the DocumentDB Insider Hour show. I'm your host, Karthik, and I am joined by Cody Allen today with us. Chad is on vacation, and we have Cody here. Cody, do you want to say hello to the group?
Yeah, hi everybody. It's been a couple of weeks since I've been here. Glad to be back. Like Karthik said, Chad's out climbing mountains, but I'm here with you today to help Karthik out. Great to be here.
All right, glad to have you here, Cody. All right, folks. So we are going to continue with our multi-part series on the well-architected lens for DocumentDB. For those that have been attending the show, in May, we did our part 1 on performance efficiency. So let me quickly switch to the agenda slide that we have in this deck. So we covered the overview and performance efficiency in May. We started this as a series, but in June, we had even more exciting new feature that we wanted to share with you. So we brought in our PM Meet Bhagdev to talk about global clusters, which is a feature we released in June that allows you to replicate data to up to 5 AWS regions, and you can use it for implementing disaster recovery and data locality kind of use cases. So we went over that and did a pretty cool demo. So had a kind of a break between these series, but we are picking it back up now. And in today's session, we will be talking about the next pillar, the next well-architected pillar. For those of you that are not aware of the AWS well-architected pillars, let me just bring the slide over here. These are the well-architected pillars that AWS has in its well-architected framework. So we talked about performance efficiency last time. Now we'll be talking about reliability in today's show. And in a subsequent show, we'll be talking about the other pillars as well. So please don't miss that. And if you like to learn more about how to implement solutions with DocumentDB following the principles of well-architected. So let's dive into the reliability pillar. So this pillar focuses on ensuring that your workload performs its function correctly and consistently, right? So basically making your database resilient to failures from network or from any outages, right? So how you can design solutions. So let's look at the design considerations. Again, if you recall, the order of these slides would be, we'll start with the design considerations on what we recommend that you implement when it comes to building your applications. So these design considerations go into focus again on the reliability pillar. So the first thing when it comes to reliability is, if you look at the slide at a high level, it's kind of split into two, right? One is around the backups, and the other is around high availability. Together, they constitute the reliability pillar. So the first few points here are about backups, right? You select the backup retention period based on your RPO or recovery point objective. Now, DocumentDB allows you to select backup, anywhere between 1 to 35 days as its retention period. So what value you select would be based on your recovery point objective. And like I was just mentioning, with global clusters, you can leverage that feature to implement disaster recovery, and that's handy, especially when you're deploying applications that have very tight recovery time objective requirements, right? So if, global clusters allows you to recover from regional level outages in about a minute or less, which is pretty awesome. So for those low RTO requirements, you can leverage global clusters and achieve higher resiliency. And then for folks that are using that have a retention requirement for more than 35 days, because the option that you get in the UI is to select up to 35 days as your backup retention period. But what if you want to retain data beyond that? DocumentDB does offer manual snapshots, and you can use those manual snapshots and retain them beyond the 35-day period, and you will purge them based on your purge requirements.
I know that when at other companies when we were using DocumentDB, we'd always use those manual snapshots to do things like whenever we had a major or minor release version that went out, we'd always want to take a manual snapshot of that data set before we made the changes to the application, so that if we ever needed to roll back or test something, we would have those. Just curious, what have you seen other customers use those manual snapshots for? Kind of that same reason?
That for sure. And also DocumentDB allows you to copy these snapshots, and you can copy these, across regions, or you can copy this, or you even share it across accounts. So think about a situation where you have a test account, right? And your QE team, your testing team has found some defect, right, in your application. Hey, what is the common thing we ask, right? Hey, I need the exact same scenario to be reproduced. I need the exact same data set. Okay, take a snapshot, share it with that account that your developer can work on a dev area, and then go ahead and test it. So those are some of the other scenarios I would say those manual snapshots, and the features it offers are really handy.
Yeah, I think that's huge, right? Is so many places I've been at, I've seen where you go to test something, you try to hand something off to your developers, and it just works, right? It works on their local machine, it works in their dev environment, test environment, and there's something to be said to be able to have a mechanism built in to relatively easily and quickly test against actual production data to replicate that. You're able to tie back to that issue or that problem that you're researching so much quicker by having that. So definitely a huge advantage there.
Yep. And you can also, within those manual snapshots, it depends on how you're encrypting your cluster, but you can have if you're using an encrypted cluster, you can have public snapshots, and you can just share it with the entire world. Let's say you're doing some open source project and you really the data is not sensitive, just open it up with the entire world. You can do those things as well.
Nice, like a third-party sharing to, that almost becomes a service that you can offer on top of your data set. I like it.
Yeah. I mean, the possibilities are endless. But again, it's still like core functionality is still taking backups and retaining it, right? So yeah. So that's again along the backups, right? So, and since we are talking about resiliency, fault tolerance, and in this pillar, we also strongly recommend that folks implement exception handling with appropriate retry techniques. This is very important, and this is not just for DocumentDB, but any scale-out architecture, right? While it has a lot of advantages with scale-out architecture, when a node goes down, another node comes back in, and there is going to be a difference, right? Like about few seconds. So implementing exception handling with appropriate retry techniques, like for example, using a exponential backoff algorithm, for example, like jitters, or it can be anything, right? And the link on this slide basically points to a blog that shows you some examples just to give you an idea. So it's always a good practice, so that let's say your application is sending writes to the cluster, and the primary instance which accepts the write goes down. What do you do, right? So you can always automatically DocumentDB is going to switch basically promote a replica instance to a new primary, but it takes as advertised about 30 seconds. Practically it takes much less than that. Still, let's say it takes 7 seconds. What should your application do, right? You don't want to lose that right. So what do? Implement retry. Use appropriate exception handling. So that's one of the important design consideration if you're really building a fault tolerance resilient application.
Would you say that it's more important for customers to retry their connection to the DocumentDB cluster, or just completely fail it, or does that really depend on the workload?
It's going to depend on the access pattern, I would say, right? So again, the blog covers what do you do in terms of when a write fails, what do you do when a read fails? Because read failures are relatively simpler, because you typically would be distributing your reads to the replica instances, and if one goes down, automatically just with one retry you would go, and what you retry is not retrying creating connection. You typically retry the operation, not the connection itself. But yeah, if the failure is at connection creation time, then you retry connection.
That makes sense. Sure.
Yeah. And then since we're talking about application level fault tolerance and resiliency, the other point is to configure your clients, for appropriate connection and cursor management. Again, connections and cursors are resources that are meant to be used frugally. Again, it's nothing specific to DocumentDB in any database, right? So you should use your connections and cursors frugally, and configure your client. For example, with MongoDB driver, let's say you're using a Java client, the default connection pool value is 100. Do you need 100 connections in the pool? Again, the answer to the question is going to depend on what's your workload, what is it doing. At peak, if you're just using 10, maybe use just 10 so that you don't have to have 100 connections in the pool, right? So things like that. So configure them appropriately. And also select, when it comes to sizing, right? Sizing is an exercise on its own. But in terms of resiliency, what is important aspect of sizing there is the number of instances, right? What is your availability target? Now, if you need 4 nines of availability, go with 3 instances. If you're saying, hey, I'm just in a lower environment, I really don't care about 4 nines availability, I'm good as long as it's 2 nines, go with 1 instance, right? Because DocumentDB's architecture gives you that high durability regardless of the number of instances. So just use 1 instance, you'll get like the data is still going to be copied 6 ways across 3 AZs. You used all 16 instances, same durability, right? So what is your availability target, and accordingly, create the number of instances. For 4 nines of availability, which is the highest availability you can get within a region, you would go with 3 instances. And then, again, in terms of resiliency, you would want to, automate your deployments so that you can, spin it up quickly without any, manual errors in place. So, use CloudFormation templates or AWS SDKs if you are into SDKs. So you can use those to automate your deployments. And, monitoring is very, very, very important when it comes to, not just resiliency or reliability, it's for all, but for reliability, it's even more important because the DocumentDB gives you more than 50, right? I think it's about 55 or more metrics at the cluster level and instance level. Monitor these metrics and, set up alarms and notifications so that, you don't have to always be reactive. You can be easily proactive if you set up those monitoring and alarms in place. So that if something goes wrong, you can, for example, you can say, hey, set an alarm when the CPU hits 75%. You don't have to wait for the CPU to shoot up and the primary to go down, and maybe your workload characteristics just change and somebody is sending more reads and writes. Just monitoring those and see if it is pegging at that level for maybe whatever, like 15 minutes, 1 hour, depending on what your workload is. Trigger an alarm and proactively scale up or address the issues of the application. And again, if you want to proactively scale up, you can monitor these metrics. You can spin up another additional instances through CLI, right? So you can kind of implement that auto scaling behavior by simply monitoring these metrics to achieve the resiliency and availability.
I've had a lot of conversations with folks about that, about the metrics and alarms and what to watch. And what's so cool about it too is it's not just a single alarm, right? It's not just saying, my CPU is really high or my memory usage is really high, things like that. It's not just a single thing that tells us something. It's a lot of times it's a lot of data points. It's, my CPU being high and my IOPS being high and my connections going through the roof and my cursors dying off, right? It's these 5 or 6 things that really mean something that collectively together, I can put, that means that I need a new instance. And I think that's one of the cool things here that, the CloudWatch alarm give us is we can put all these alarms together and create like a composite alarm. So if these 5 things happen or these 6 things happen, I know definitively that something needs to happen. Maybe my CPU being high just means I need to go look at it, but my CPU being high with all these things, you do what you're talking about, right? You create a script that adds another instance, because I don't know about you, Karthik. I've spent a lot of times in my career working on databases, and I've learned if I can be lazy and let an automated system do it for me, that means I don't have to wake up at 3 a.m. to fix it. And that's the way I like to operate.
Yeah, I would just tweak that. It's not being lazy, it's being smart.
I like that. That's going on my resume. I was not lazy when I did this. I was smart. That's much better.
Yeah, no, I agree. I mean, again, DocumentDB is a native AWS service, right? So you get out of the box integration with CloudWatch, CloudTrail, and with CloudWatch, you can do these monitoring alarms pretty easily. And even better, if you have multiple clusters, you can monitor all of them within one dashboard. So, how cool is that, right? Like in a command control or a support center, you just have that on one screen and monitor all of them in one place. And, if things goes out, automatically send emails. And you can also, not just emails, you can trigger a SNS topic, call a Lambda function, and, just remediate the situation right there, right? Or you can automate it to the nth level. So, yeah, you can take it to the level you want it to. It can be as sophisticated as you want.
That's awesome. Yeah, that's huge.
Mm-hmm. Cool. So, those are the design considerations. Let's now we'll look at like some of these and also explain these concepts to you in terms of what DocumentDB offers. Right. So the first one is we talked about backups a little bit. So backup in DocumentDB is continuous, incremental. And like I said, it has a retention period. You can select up to 35 days. And the storage and compute, if you are not familiar with the architecture, DocumentDB has like decoupled storage and compute, right? And the backup is one of the tasks that is offloaded to the storage layer, which is very important to understand because, unlike other databases where, you need to have a dedicated instance to perform backup, in DocumentDB, you don't even see an instance that is doing backup because it's all offloaded to the storage layer, and your instances, the compute instances that address your application queries, do not participate in backup at all. So what this means to you is they're completely freed up to perform your application request or process your application request, which is basically query processing, right? And let the storage volume, the distributed storage volume in DocumentDB perform the backup operation. So there's no impact to your application. Literally, you can take backup during peak traffic without bringing your system down to a grinding halt. And also automated snapshots are created on a daily basis to maintain an incremental record of database updates within that retention period, right? So if you chose a retention period of 7 days or 1 week, right, we create those automated snapshots at a time that you tell us during the cluster creation. And DocumentDB will automatically maintain those automatic snapshots. And it's a rolling window of that 7 days now. So you start on a Sunday, you go till Saturday, next Sunday, so, the prior Sunday will be dropped. So it's a rolling window. When we talk about manual snapshots, you can take this to retain data beyond that retention period. And these, unlike automated snapshots, these are like full backup of your cluster data. And DocumentDB also offers point-in-time recovery. So if you, in our example, let's say you did a 7 days retention period, you can go to any point in time in that retention period and say, I want to restore the data from here, right? So that is pretty huge, right? We are like at the scale that DocumentDB operates, where you can go up to 64 terabytes in terms of data. And let's say within that 1 week you have a lot of data, you can still go to a specific point in time and say restore all the data into a different cluster. So point-in-time recovery is available to you. So if you know exactly at a point where somebody ingested wrong data or something wrong happened, you can just say, okay, get me the data before that point, and let's start from there.
I think it's really interesting. The first point that you brought up is pretty cool, right? Because a lot of self-managed, on-prem hosted, or even things that we put on ESX or even on AWS. A lot of times you have to plan for the impact that backup's going to have on your production workload, right? Mm-hmm. So if I have 2 servers, maybe I need to have a third one so that my backup can run against that third server and my first 2 can handle the normal workload. Mm-hmm. And that seems easy to say, and it's easy to draw it on paper, but behind the scenes, man, that means that I have to manage another operating system. I have to manage another server. I have to manage, patching of it, and not just the database patching, but the OS patching. But so it's kind of cool that the backup architecture here, since it goes from that storage volume, kind of reverberates up to the front end too, right? So now when I'm designing the size of my cluster, for example, or designing the footprint of my front end databases, backups doesn't have to play into that anymore. Backups its own thing that doesn't interfere with those clients at all.
That is correct. So yeah, extra server, extra personal cost. Guess what?
Right,
all of that
yeah.
adds up to? It all adds up to extra money. So,
that's getting into my lazy time. I don't like that. I'm not my smart time. I'm sorry. Yes.
Smart time. That's right. Yeah. Yeah. So yeah, I mean, you're absolutely right. So it's more, again, benefits of fully managed service, right? Remove that undifferentiated heavy lifting. It's those are mundane tasks that no longer need to be done by a dedicated resource, right? That resource can probably do much more high performance tasks like tuning queries, for example, which is what is required for providing an excellent experience for your customers. So that's all about the shift, right? Where we were working like a decade ago, which areas we're going to be focusing now, and it's going to change as we go forward.
100%. Yep.
Cool. And manual snapshots versus automated snapshots, just a quick comparison, right? So like I said, manual snapshots are full backups and automated snapshots are incremental and created on a daily basis. And when it comes to how we charge, just again, I know we're not at a cost optimization pillar, but still, so while we are here, incremental value of storage is what our customers are charged on. So if you bring in, let's say, 10 terabytes of data, you're not going to be charged on the initial load. You'll be charged on the incremental value. So you see here, some examples of the differences, right? Like how you name it. Again, you cannot name an automated cluster snapshot. It is automatically named by DocumentDB, whereas you can name it in when you create a manual cluster, manual snapshot. Same thing as with creation, right? It's automated snapshots is created by DocumentDB in a schedule that you define, whereas manual snapshot, you can create your own schedule because all these are available through CLI, but it is still on demand, right? Because you invoke it, not DocumentDB's control plane or DocumentDB's processes. And then important to understand is automated snapshots will be deleted right after your retention period. So I was talking about that rolling window. So it gets automatically deleted. In other words, automated snapshots lifecycle is managed by DocumentDB, but manual snapshots, if you create them, it's your responsibility to delete it because we do not know when you need which snapshot. So we'll not be deleting that on your behalf. And then it's automated snapshots are incremental and manual snapshots are always full backup. And when it comes to restoring data with automated snapshots, you basically do a point-in-time recovery. And manual snapshots, it's basically at the time the backup was taken. So it's going to be a full restore. And when it comes to sharing, you cannot share an automated snapshot. So I was talking about copying to another region and sharing, and also sharing can be done only with manual snapshots. And you can have about 35 manual snapshots per cluster because the maximum retention period is 35 days, one per day, that is 35. And manual snapshots is about 100 per AWS region.
So for creation here, what you're saying that is the automated ones are going to happen. I don't have to do anything for that. That's a built-in mechanism for the engine. For the manual snapshots, I mean, I could script that, right? Like I could do some kind of mechanism to, if I needed a full backup every day for whatever reason, I could do something that makes that happen, right?
Absolutely. Yeah. And even better, actually, with manual snapshots that fall within the retention period. Let's say you have a 7 days retention period and manual snapshot you're taking in the same time, there is no additional cost. But since it's a rolling window, once it goes outside the retention period, then you'll start accumulating charges.
Very cool.
Yeah. Cool. And then, some operations, like if you've not been to a DocumentDB, console, if you go to the console, this is how you take a snapshot. It's pretty easy. You just select the cluster identifier and say, I want to take a snapshot, or I want to restore to a point in time. You can do all those things. And if you want to do a full restore, there is a snapshot menu on the left. You select that and just say, go to actions and say, I want to do a restore from the snapshot. So very fully managed service, right? So it has to be simple. So we try to keep it simple for our customers. And then since we're talking about reliability, the deployment options, right? So how can you deploy DocumentDB, right? You can deploy, like I said, even just one instance, which obviously is going to be your primary instance, which will take writes as well as allow you to perform reads. This is going to be in a single AZ. And this is again, when this goes down, there is going to be a recovery time of about 10 minutes. But again, the durability is the same. It's still the data is replicated 6 ways across 3 AZs, and you get high durability. So the availability target is going to be 2 nines or 99% availability. Now, if you look at the one in the middle here, this is like a 3-instance deployment, right? You can do a 2 or a 3-instance deployment where the first one is going to be primary, the other 2 are going to be replica instances, and here you can perform the reads from the read replica. Basically, you're scaling your reads using the scale-out architecture now, and you get like 99.99% availability if you're using 3-instance, or 99.9 if you're using just 2-instance. And for production, we recommend at least 2-instance if you're okay with the 3 nines of availability. If you want 4 nines, you can certainly use 3 instances. And with global clusters that we recently launched, you can also expand this, the one that is in the middle, you can basically convert that regional cluster into a global cluster, and you can do cross-region replication of data and perform reads on the local. So from a resiliency or reliability pillar standpoint, it's more for disaster recovery. But if let's say the primary region goes down, you can just switch to that region, and you can promote that region into that cluster in the secondary region into a standalone cluster and start performing reads and writes. So again, the replication in this case is between storage, and I'll cover that in a bit. And it's generally very fast because it's a physical replication. So
I was having a conversation yesterday with somebody, and they were talking about that SLA, that availability. The 2 nines versus 3 nines versus 4 nines. What does that mean, right? And then you look at something like S3 that has 11 nines of durability or availability, and they said, what does that mean? What do those numbers mean? And it's interesting because I found a chart, and I'm gonna have to find it again, that
Cody,
tells you
you're muted. I don't know.
Oh, can you hear me now?
I was muted too. Something happened.
How about now? Am I back?
No, you're still muted.
Test 1 2.
Okay. Yeah.
Okay. Continue on.
Everybody else can hear. I don't know. Just check if your mic settings has changed, Cody. I don't know. I was muted for a bit as well. I don't know what's going on.
How about now?
No. I can see you, but I can't hear you.
Keep going. Keep going.
Okay. So we'll push along while Cody is fixing his technical difficulties and challenges with StreamYard here. Okay. So let's look at the regional cluster operations, right? So if you take a cluster and within a region and what you can perform there, right? What features it has, like you can configure up to 15 read replicas, and you can leverage automatic and fast failover. So if a primary instance goes down, you can always bring it automatically. DocumentDB will bring up as a replica instance to be the new primary. So again, those are all automated for you, so you don't have to worry about it. So as long as you have at least one more instance in the primary, it automatically fails over, switches over to the replica instance in case of a primary instance failure. And you can, if you go to the cluster console, you get the endpoint, cluster endpoint, and you can connect as a replica set. So those are all within a region what you can do. Now, global clusters, like I said, is a brand new feature released like just last month. And with this, DocumentDB now allows you to replicate data to up to 5 secondary AWS regions, right? So again, the replication here is offloaded to the storage layer, right? This is physical replication from the storage layer of the primary to the storage layer of the secondary. And this being physical, it's like the replica lag is very, very low, typically less than a second. So, when would you use global clusters, right? So global clusters allows you to recover quickly from regional outages. Let's say you're running in US East 1 and US East 1 is down. Again, this is very, very, very rare scenario. But let's say a region goes down, then you can promote a cluster in a secondary region. You could be running that in US East 2, US West 2, EU West, wherever it is, right? Like anywhere in the globe. You can take that secondary region and promote it to a standalone cluster that can then start accepting writes. And this
Karthik,
process takes less than a minute, providing you, very low RTO, support. So if your application requires low RTOs or like, RTOs within a minute or so, then this is a great feature. Also, once you replicate the data to that other region, you you can also perform reads on the data from the secondary region. So in this example, if you go to Tokyo and if you have an application in Tokyo, you can perform reads, and the data from in the primary region, which is Ohio, will be replicated to Tokyo in less than a second. So your applications in Tokyo now can read data that was written in Ohio in less than a second latency. So providing a very good use case for data locality, where you can now do local reads for your application that is globally distributed.
Karthik, can you hear me
so
now?
That's again a great feature for resiliency. And here is a kind of a reference architecture, right? So let's say you have data locality on the left-hand side. We have disaster recovery. So here you can read the data on both US East 1 and US West 2. You can write the data into the primary, which is on US East 1. Whereas let's say, if this US East 1, which was the primary accepting writes, went down, then you can always, promote this US West 2 into a standalone cluster in less than a minute's time, and your users will now start writing data there and also reading from there. And you can certainly start building another global cluster on top of US West 2 now, if you want to continue maintaining that global clusters and have multiple regions for resiliency. So from an availability standpoint, we already talked about it. So if you want like 4 nines of availability, then use 3 instances. But anything more than that, if you use like 4 instances, you're still going to get 4 nines of availability. So that's something that we did not mention before. So 4 nines is the maximum availability. Anything more than that, you will be using those reader instances only to perform higher read scalability. If you want to do like millions of reads per second, then you keep increasing your reader instances to do more, perform more reads. All right. And some metrics to monitor for reliability. So the database cluster replica lag maximum is a good metric to monitor. This basically tells you what is the amount of lag in milliseconds between the primary instance and each of the replica instances within a cluster, right? So again, if this is typically between 10 to 100 milliseconds on an average at about 20 milliseconds, and it's not a problem when it comes to system stability. Even if it goes up to a second occasionally, it's not a problem. But anything more than that, that's something that you should probably look into it. And database connection, again, this metric will tell you the number of connections that are open on a instance in your cluster, and it is generally recorded at a minute or 1 minute frequency. And one thing about database connections is it scales with the instance type. So for the largest instance, you can have up to 30,000 connections per instance. So which is a large number, but again, why would you go there, right? Like make sure that you're frugal and using your database connections. The database cursors, on the other hand, is another metric that you want to monitor. This tells you the number of open cursors on an instance in that 1 minute frequency. And again, this limit also varies by the instance type. So the maximum value here is 4,560 for the largest instance. So again, it's strongly recommended that you create alarms for both the database connection and cursors when they hit that 80% limit, so that you can be proactive and scale your instances, or at least figure out why those connections are going up, and see if the application can be tweaked to fix it. Now there is a metric called database cursor timeout. This tells you the number of cursors that were timed out in a 1 minute period. Basically, how many cursors were idle and hence reaped by DocumentDB. DocumentDB will look for cursors that are sitting idle for like a 10-minute window. Then it'll go and read those. Again, it does that to, again, clean up resources, but that's not an ideal way to manage cursors. You would want to proactively close those cursors in your application. Then write latency and write throughput. Again, it tells you, in terms of the data that is being written into DocumentDB, latency is, in milliseconds. What is the time in milliseconds for the disk operation? And throughput is, how many bytes are written to the disk per second. So these are good metrics to monitor when you do a performance testing and benchmark these, and then set an alarm. If you, let's say you're benchmarking the write latency at say at 10,000 per second or whatever write operations were supported during your stress testing, then use that number, and if it goes beyond that, set an alarm and see why is it going beyond it. Has the workload characteristics changed? Should you consider any scale operations and so on? And then, it is also important to address the memory and CPU exhaustion, and which can result in instance crashes, right? So again, we're talking about building reliable applications. So what are the things that could cause the memory and CPU to exhaust and cause the instance to crash, right? So it generally it's around this query and connections and cursors. So let's look at each of these here. When it comes to query, it's important to understand that DocumentDB does not reserve memory on a per query basis or per connection basis. So each query will consume memory. And if you have too many concurrent queries, that is going to increase memory consumption. So one approach that you can follow to reduce the memory consumption because of concurrent queries is to just reduce the max pool size, because that is going to reduce the number of connection, which is going to reduce the concurrency. And those are again for reads, but also for writes, right? If you have too many writes, that can result in CPU exhaustion. So look for that write latency, the metric I was just mentioning, right? If it is high and if the write throughput is maxed out, there is a chance that you're having too many concurrent writes, which can result in the next thing that is going to be affected is the CPU, right? So monitor those write latency and throughput, and then scale accordingly. So that's why I included that in the metrics to monitor. And then if you have aggregation queries, look for each aggregation query, and if it is exceeding 512 MB in memory consumption, that is too much memory. If you hit that level, that is very high. So what I would suggest there is to use the parameter called allow disk to true, because that will allow you to perform aggregation operations on the disk as opposed to memory, so that there will not be any memory consumption or memory exhaustion issues. And if you have long running queries, be aware that you may be terminating it on your application side, but they are still running on the database side. So those abandoned queries, make sure that you're killing it using db.killop. And then on the right-hand side, we have the connections and cursors. So we talked about this, right? So if you have too many idle connections, that is going to result in memory consumption. So generally, idle connections will hold on to the buffers that are used for TCP socket read and write. So how you can address this is by reducing the max idle time, because what will happen when you reduce the max idle time is the idle connections will be closed sooner than later, and that will help with the memory consumption issue. And then monitor the database connection metric, and like I mentioned just in the previous slide, and reduce the connections in the connection pool so that you can conserve memory. Or if you cannot, let's say those connections are all required, then consider scaling up your instance. And then again, similar concept applies for the cursor as well, right? If you have too many cursors, they consume more memory. So close those cursors when they're not in use, and then monitor the database cursor timeout metric, because that tells you that your application is leaving open cursors, and DocumentDB is timing out in 10 minutes, timing the cursors out in 10 minutes. So close those. It's an opportunity for you to go and talk to your application team and get that resolved. And then, if I put that slide that we just discussed in a picture, right, this is what it looks like. It basically creates a feedback loop if all those issues happen, which starts pretty much with the slow query, right? So that's why it's always a good practice to identify and optimize those slow queries, because when slow queries do pile up, then you get into a feedback loop, right? So for example, slow queries would cause increased concurrency, which could result in increased memory consumption. that can result in increased swapping and then lock contention and increased CPU context, which can cause further slowness. So that feedback loop, you would want to avoid that, right? Because if you just let the slow query, continue, operating the same way, then it's going to eventually become slower and slower because of this feedback loop. So always address those CPU and memory exhaustion issues and slow query issues without delaying further. And the last slide for today is on what are the questions that you should be asking, right? How can you put all these things into practice, whatever we discussed today? So the first one is how are you meeting your RPO and RTO with DocumentDB, your recovery point objective and recovery time objective? Because that is going to help you determine what that backup retention period should be, what the deployment should be. Should you use global clusters, or can you just copy those snapshots and move it into a secondary region to recover from a region-wide outage? It's all going to depend on what your RTO is. If you tell me that your RTO is 24 hours, 48 hours, maybe you can just copy the snapshot and move it. It'll be economical. But if you say, hey, I need a 15-minute RTO, then go for global clusters, right? And then how do you support disaster recovery requirements? Again, it's kind of tied to your RTO, but okay, what is the need there, right? Will global clusters help you, or what is your BCP or business continuity plan when a region goes down? Right, so those again, global clusters. It could be copying the snapshots. It could be how you are even on the application side. How are you deploying your applications? How are you externalizing your endpoints to connect to DocumentDB, and so on. And then how does your application handle exceptions? So we talked about the importance of exception handling, right? Like retry mechanisms, exponential backoffs, jitters, especially in the scale-out architecture. It is super important. So make sure that you have that in your application and answer that question, right? Are you just doing a simple try-catch, or are you really looking for specific exceptions and handling them appropriately, so that when a write outage or write failure happens because the instance is down, how are you making sure that write is not lost, right? So all those will be handled in your exception handling mechanisms and related code changes. Then how do you manage your client connections to clusters? Again, connections and cursors are frugal resources. Are you using appropriate value in your connection pool? Right? Are you using appropriate value for idle max time and so on? Right? So make sure, one is how many connections should be in the pool, and then is how long should they be? How long should it be before you reap them off because they're idle? And then your HA deployments, that's going to basically determine your number of instances, right? So how do you want to support your high availability requirements? And then how do you automate your database deployment? Do you use CloudFormation? Do you use SDK, AWS SDKs? Or some customers do use Terraform. It's all acceptable, but as long as you have a plan for that automated deployment, so that if you want to spin up a cluster in any environment, you should be able to do it without requiring a manual effort there. And lastly, how do you monitor the reliability of your workload? Those I think six metrics that I shared before. Those are some of the key metrics. I mean, you can choose more metrics from the available 50 or 60 metrics we have, but at least those metrics, are you monitoring them? Not just monitoring, what are you doing based on the monitoring results? Are you setting appropriate alarms? Are you proactively notifying right folks? Or do you have automatic remediation through SNS topic Lambda function integration? What is your requirement there, right? So it's important to monitor and also implement those appropriate reliability, implement appropriate alarms to ensure reliability of your application. So that's all I got. I know we unfortunately we lost Cody because of technical issues. Let me see if there is a way for me to get him in. Let's see. I don't see a way to get him in, but let me try to find if there were any questions. I don't see any questions. If folks have questions, feel free to put that in the comments. I'm trying to get to the comment screen here. Oh, that is Cody. Sorry about that, Cody. Can you hear us okay?
I can hear you. Can you hear me?
I can. There you go. All right, I found you.
How can I improve the reliability of my microphone, Karthik? That's what I want to know.
Use DocumentDB.
Hey, there you go.
Yeah. So do we have any questions from any of the audience there? Do you see anything, Cody?
No questions. We're watching the chat. If anybody has anything that they want us to follow up on or dive deep into, let us know. If there's any questions we can answer. This isn't unique, right? I mean, this is something that if you've been in the database business for a year or 20 years, this is something that we've all been chasing down, that HA architecture and disaster recovery, right? That's the part that's hard about our job sometimes is dealing with those. I guess anecdotally, what do you see customers doing with DocumentDB as far as global cluster deployments? Like, what is talk about some situations where customers are using the global clusters to help with this?
Yeah, great question. I mean, like before we launched this feature, we had a lot of requests from our customers of all sizes, right? Like larger enterprises, medium enterprises, and so on. Their primary ask was for disaster recovery because one of the complex problems in database is replication, right? It's not just easy to do that replication, right? So and the way AWS solves it is even better because it's at the storage layer and it's physical replication just happening in less than a second is phenomenal. So customers, when I was talking to a lot of our large customers, they were like, we have very strict RTO requirements. We cannot, we are using DocumentDB for our mission critical workloads, like a tier 1 application. If it is down, it's going to result in significant revenue loss. So we need to make sure that this is highly resilient, and our recovery time objective, it was a wide range. The lowest I've heard is 10 minutes. And for those tier 1, some applications were okay with about an hour. But the challenge there is, okay, why can't you just copy a snapshot and be done with it, right? Snapshot copy. DocumentDB customers use it for data at high scale, and obviously when you're having terabytes and terabytes of data, copying it over a network, in a law of physics, it would tell you that it takes time, right? So they needed much more sophisticated solution that replicates real time, and that's the only way to achieve a lower RTO. So primary use cases I've heard is around RTO. Now I've talked to a few customers that are globally distributed, like they have they use regions, 2 or 3 regions in the US. They use regions across across the world, and they have people that are traveling all over, right? So they want to make sure that they get access to data, because these are all application modernization kind of initiatives where they need quick access to the data. They cannot just sit and look at the spinner, right? Where the request is routed to across the globe and then get the data. Those days are gone. People want the data right now and right here. So that data locality aspect is also very important. That's why we said, okay, we'll not just replicate the data, we'll let you spin a cluster so that you can also read the data. But I would say, it's 60-40 if I were to put a percentage for disaster recovery versus data locality.
I remember reading something. I don't know if it was shared on a presentation that we did, or if it was some other conference I went to, and they were talking about the impact slow application has to a customer experience. Just about how, and it was down to the 10th of a second. If a customer has to wait an extra 0.2 of a second or 0.3 of a second, they're gonna go to a different page, right? Or they're gonna look at a different product, and that speed that getting that response back on my phone as I'm looking up a product is huge. And that's interesting, right? Because now we're not talking about just the reliability aspect of it. You're talking about, hey, you're gonna get that, right? You're gonna get that reliability, so that if something happens, you can fail over and your recovery time objective goes down. But guess what? In addition to this, you're also getting a better customer experience. You might be in Virginia, but now you're going to make your experience better for your customers in Japan or India, because that's where you have your global cluster. That's cool.
Absolutely. Oh yeah. So it's I mean, like what you said literally translates to what I've heard in the application modernization initiatives, like from these CIOs and others, right? It's like if you cannot give the performance at the same rate as your competitor does, or you cannot beat it, you're losing customer to the competitor. It is that cutthroat right now, right? Because this generation, like the Gen Z, Gen X, all they cannot wait for data. It has to be like instantaneously available.
I'm like that too anymore. Well, and it's neat too, right? Because everything that we've been talking about so far with we'll call it the monolithic design, the old way of doing things, where I have to add servers to make up for backups, and I have this huge data transfer to do the replication. That's all been focused on internal mechanisms to make sure that we're reliable, right? That we're operational. But what this does by offering something like that global clusters is it goes beyond just making sure that we're operational, functional, reliable. That goes back to one of the big things that AWS has, or one of our big leadership principles, is customer obsession, right? We are able to implement features that makes our workload, our architecture more resilient, but we get to focus on our customers by making their experience better. And you're right, speed. I'm like this too. If I go to a website and I sit there and I wait and I wait and I wait for it to spin, I'm going to leave, right? And it's dumb. What's it going to hurt me to sit there for an extra 5 seconds, waiting for it to load? But that's what we do, is we leave. So by having that endpoint close to your customers, I think that's huge. That's such a great experience for organizations' customers.
Absolutely. Yep. It is huge.
Well, no more questions in the chat room. And I'm all out of questions myself. I feel like I understand the reliability portion of this a lot better. So thank you.
Absolutely. Yeah. I hope.
Oh, hey, we did just get our first question here. So the question is, global or multi-AZ clusters can create multiple clusters in each region, or are they in the same VPC? Yeah, there we go. And how would you communicate a server to the clusters, or is there a better option to administrate DocumentDB?
All right, so multi-AZ, I'm just going to read this question again. Global or multi-AZ clusters create multiple clusters in each region. Yeah, they are in the same VPC. Now, I mean, they would be in their own VPC in those regions. And how would you communicate to the server? I presume this is how do you communicate from application server to the DocumentDB cluster. So it's going to be like, let's say you have 3 regions, right? You can have up to 6 regions in total, 5 secondary and 1 primary. Each of these clusters are going to be, in its own region, in its own VPC in that region. And of course, the primary can talk to all these because it has to replicate the data. The application server, again, DocumentDB is a VPC-only service, and for security reasons, you don't want it to be exposed out. So the application also, we recommend that it resides in the same VPC, unless you can do VPC peering if that is permitted in your organization. But we recommend that you have the application running in the same VPC as your cluster. So in the slide that I was talking about earlier, let me bring that up again here.
Hey, Karthik, I feel like I'm playing peekaboo behind the logo here.
Let me get that off. Sorry.
I feel bad. People just see my forehead. There we go.
Okay. So if you look at the slide here, right? So the app 1 would be in the same AZ as your primary, and app 2 would be in the same VPC as the primary, and the app 2 would be in the same VPC as your Tokyo region in this case. So yes, you'll have your application server running in the same VPC as the DocumentDB cluster. So if you have like 3 regions, you'll have 3 application servers in those 3 VPCs. But each of the DocumentDB cluster will be in its own VPC.
Yeah, and that's a construct of AWS. You know, a VPC just exists within a single region. But yeah, I mean, because we're doing that replication from the storage engine, you know, you're going to get that taken care of. But you definitely want to make sure that that's one of those planning things, one of those exercises in architecture that if you do plan on failing over to that secondary region, just make sure that you're thinking about how your application is going to communicate back to it as well.
Yep. Great question.
And the second part of the question, did we answer that? How would you communicate a server to the clusters, or is there a better option to administrate DocumentDB?
Yeah, I thought that's what we were saying, right? Like, I think communicate a server is basically the application server to, I presume that's what it is. Otherwise, maybe just you ghost the user can probably correct the assumption. But yeah, you would be like running the applications locally in each of those VPCs. And how would you administrate it? I mean, it's a fully managed service. So there is, I don't know which part of administration you're talking. If it's about provisioning, yes, you would be, you can use CLI, or you can create it through the console.
Josu, maybe you missed the whole let's be lazy, smart DBAs discussion. That's what we're aiming for here, right?
It's true.
Awesome. Well, no more questions in chat that I see. So I think we're good.
All righty. Awesome. Thank you so much, folks. Appreciate your time. And we will meet again next month. And that time we'll talk about other pillars like cost optimization and so on. So please do join us for the next Twitch show, the DocumentDB Insider Hour. Until then, take care of yourself and stay safe. Bye-bye.
Good seeing everyone.
Mm-hmm.